Swapnil sir and welcome to yet another video on our channel Euclid Mathematics. We have started lecture series on NDA and NA previous year question paper 2021. So within that I already uploaded plenty of the videos on my channel. So if you wanted to see this video, you may go through my videos. Now in my today's video, I'm going to explain to you all one of the latest question from National Defense Academy and Naval Academy previous year question paper. Now let's get start our question. First of all, I'm going to explain to you all the question and then we'll go for the detailed understanding of solution. So in our question, we have given if log to the base 10 of 2, comma, log to the base 10 of 2 raised to x minus 1, and third term is given log to the base 10 of 2 raised to x plus 3. Okay, if we have three of these terms are in arithmetic progression, then we have to find out the value for x. Okay, so what is the value for x? It is possible here. Okay, first option it says that the value for x is 0. Second option it says that the value for x is 1. Third option it says that the value for x is a log to the base 2 of 5. And fourth option it says that value for x is a log to the base of 5 of 2. Okay. Now let's get to find out the solution for our today's example. Quite easy question. We have to apply some basic concept from arithmetic progression and easy calculations are this. Okay. So now let's get start. Solution. We have given three terms. Okay. First term it is here log to the base 10 of 2. Second term log to the base 10 of 2 raised to x minus 1 and log to the base 10 of 2 raised to x plus 3. Okay. Now let's consider the first value as x, which is equal to this, y which is equal to this, and z which is equal to this. Okay, for our better understanding. And we know that if three terms are in a arithmetic progression, then we write their arithmetic mean. How can we write their arithmetic mean over here? So arithmetic mean for three terms, we write middle term which is equal to addition for remaining two terms x plus z and divided by number of terms. Okay, so y which is equal to x plus z by 2. Okay, when we have three terms in arithmetic progression, then we write their arithmetic mean this way. Okay, so if you have nth term, then you have to add all n term and divide it by n. Okay, this is the arithmetic mean for nth term. Now here we want we have given arithmetic progression over here, and then apply this result for arithmetic mean to our given data and then find out the value. Okay, now here what is the value for y? Log to the base 10 of 2 raised to x minus 1. So it is here log to the base 10 of 2 raised to x minus 1, which is equal to x plus z. So this first term is x here and last term over here is as z. Okay, so log to the base 10 of 2. So first term is here log to the base 10 of 2 plus z, it is here log to the base 10 of 2 raised to x plus 3. Log to the base 10 of 2 raised to x plus 3. So log to the base 10 means, what is mean by log to the base 10? It is a common logarithm. Okay, so always we take it into logarithm. Okay, so it is common logarithm we always use in our calculation. Okay, so upon 2 here. Okay, so go for solving this step and let us see what we'll get from our solution. Just we have to find out the value from both of these sides. Okay, it is like a solving of a polynomial. Okay, okay, now let's take this 2 over here. So 2 times log to the base 10 of 2 raised to x minus 1, which is equal to log to the base 10 of 2 plus log to the base 10 of 2 raised to x plus 3. Okay, so by using exponent rule, we can take that multiple 2 to the power over here. Okay, so log to the base 10 of 2 raised to x minus 1 to the power 2. Okay, 2 it is common at the power. Okay, this is a exponent rule for logarithm. Okay, so log to the base 10 of 2 raised to x minus 1 to the power 2, which is equal to log to the base 10 of. Okay, now here we can see log of a plus log of b. So how can we write log of a plus log of b? This is a standard rule for addition in a logarithm, that we write log of a multiplied by b, which is equal to log of a plus b. Okay, log of b. Okay, so how can we write log of a multiplied by b? We can write log of a plus log b. Okay, this one is the standard result, always remember. So we have to apply this result over here. So log to the base 10, it is common over here. So 2 multiplied by 2 raised to x plus 3. Okay, 2 multiplied by 2 raised to x plus 3. So whenever we have to cancel this logarithm from both of the side, we apply the exponential term. Okay, and whenever we apply the exponential term, logarithm will get cancelled. Okay, so apply over here, apply exponential term. exponential term to both side. Okay, so we have to apply exponential term to the both sides. So log and exponential, it will be getting cancelled. So e to the power log, okay, e and log will get cancelled. So under bracket we remain over here 2a is to x minus 1 bracket square. Again exponential term and log to the base 10, again it will be get cancelled. So under bracket we are left over here with 2 multiplied by 2 raised to x plus 3. Okay, so how can we write 2 multiplied by 2 raised to x plus 3? So 2 raised to 1 into 2 raised to x. So we can write 2 raised to x plus 1. Okay, so how I have written over here. So I return 2 multiplied by 2 raised to x as a 2 into 2 raised to x, and when base is same we add their power, plus 2 multiplied by 3 which is a 6. Okay, now see that how easy it is. So now we got the easy polynomial by using our given data. Okay, and we have to solve this polynomial for the value of x. Okay, now first of all find out the square a minus b square. So what is the value for a minus b square? A square minus twice of ab plus b square. Okay, apply this result over here. Okay, so we'll get the simplified form. So a square, that means 2 raised to x raised to 2 means 2 raised to 2x minus twice of ab 2 raised to x plus 1. Okay, 2 times ab means 2 raised to x into 1. Okay, so 2 raised to x into 2 raised to 1, that means 2 raised to x plus 1 plus b square, that means 1 square, it remain 1. So 2 raised to x plus 1. Okay, 2 raised to x plus 1 plus 6. Okay, that positive term and that negative term over here, take all these terms together and find out the calculation. These are the easy calculations. So 2 raised to 2x and that 2 raised to 2x plus 1, take it here. So it is 2 raised to 2x as it is. 2 raised to 2x plus 1, it is here as a 2 raised to 2x plus 1. Okay, so negative it is coming here. So negative negative, then we get the negative 2 times 2 raised to x plus 1. Okay, the two terms are similar. 2 times 2 raised to x plus 1 it is coming. So take this term over here. Okay, it is coming negative. That one is negative as it is here. 6 minus 6 it is here. Plus 6 it is here, minus 6. So 1 minus 6 it is minus 5. Okay, now let's get to find out the next step. Okay, in our next step we can write here 2 raised to x to the power 2. Okay, 2 raised to 2x I written here, 2 to the power x to the power 2 plus it is not there, now it is negative coming here. So 2 to the power x multiplied by 2 to the power 1. Okay, so 2 to the power x multiplied by 2 to the power 1 I written this way, minus 2 to the power x multiplied by 2 to the power 1. Okay, two terms are similar, that means 2 to the power x minus 2 to the power x into 2 to the power 1, it is two terms are here. Okay, then we can write 2 times the one term. Okay, minus 5 which is equal to 0. Okay, so we have to find out the quadratic equation over here. So here we can observe, it seems like we have quadratic equation. Okay, ax square plus bx plus c in the form. Okay, but we have, it is quite confusing ax. Okay, so try to substitute the value for 2 raised to x, then we can get the simplified form of our given quadratic equation. Okay, now let's substitute some value for 2 raised to x. Okay, now put 2 raised to x as y. Okay, now to put something value for 2 raised to x, so put 2 raised to x which is equal to y. Okay, so if you're going to substitute 2 raised to x in y, so we'll get the quadratic equation y to the power 2 minus 2 raised to x is y into 2, y multiplied by 2 minus y multiplied by 2. Okay, so it is multiplication over here, minus 5 which is equal to 0. Okay, so 2y minus 2 minus 2y minus 2y minus 4y, so y square minus 4y minus 5 which is equal to 0. Now we got the quadratic equation over here. Okay, so it is easier to find out the value for y by using this quadratic equation. Okay, value for y means it is the root for y. Okay, now let's find out the two term where multiplication addition hold for these two terms. Okay, so we need the two term, their multiplication is a negative 5 and their addition it should be negative 4. Okay, so which is the possible term? So negative 5 multiplication negative 1. Okay, what we have possible chances that can we get the two term as a negative, multiplication as a negative 5. Okay, so and their addition we need a negative 4. Okay, so negative sign for bigger element, so we can take 1 multiplied by minus 5 and 1 minus 5. Okay, so we have two roots here, 1 multiplied by, so which is a y plus 1 and y minus 5, okay, which is equal to 0. So these are the two roots, okay, that we need one term, two terms, their multiplication negative 5 and their addition is a negative 4, okay. Their addition negative 4 means minus 5 plus 1 is a negative 4, and their multiplication minus 5 into 1 minus 5, okay. So I got the value for y is 1 and y which is equal to negative 1 and y which is equal to negative of positive of 5, okay. So we got the two roots for our quadratic equation, okay. What is the root? Y is a negative 1 and y which is a positive 5, okay. But as we have, what is the value for y? I consider here 2 raised to x, okay. Y which is a 2 raised to x. We consider here substituted here the value for y is equal to 2 raised to x. Now which value for y is possible over here, okay? Which value is possible? Because 2 raised to x, the term which is a never negative, never 0, okay, this term never coming negative, okay. Any value for x you substitute, even if you substitute x as a 0, then 2 raised to 0 you will get 1. Even if you substitute x as a minus 1, minus 2, minus 3, that term coming 1 upon 2 raised to something, but it is a positive, okay. That means the value for y which is negative never possible, okay. The value for y which is negative never possible. So y which is equal to, which is not equal to minus 1, okay. This implies y not equal to minus 1. Why not equal to minus 1? Because of that y which is equal to 2 raised to x, it is always positive term, okay. Now what is the value for y? It is remaining possible here, y which is equal to 5. Now put value of y which is equal to 5 in our substitution, okay. So 5 which is equal to 2 raised to x, okay. Now we want the value for x. So how can we find the value for x over here? Now here we can see x is a power of a 2, okay. That means 2 raised to x which is equal to 5, okay. Now we have to apply the definition of logarithm here, okay. So a to the power x which is equal to b, then we write x which is equal to log to the base 2 of 5, okay. What is the definition for logarithm? Let me explain the definition for logarithm to you all. When we have term a to the power x which is equal to b, then we write by using logarithm x which is equal to this term which is equal to log to the base a of b, okay. Then we write x which is equal to log to the base 2 of 5, okay. So this is the required answer, okay, which is given in our option number C, log to the base 2 of 5, which is a correct answer, okay. I hope you all have understood my today's solution. It is quite easy solution that we have to apply some basic concept, okay. Easily we'll get the answers, okay. Just rules of logarithm it is needed, okay. So I hope you all have understood my today's lecture. Even after, if you found anything difficult in my lecture, let me know in comment section. I will come up with some other videos. So thank you everyone. Thank you for my today's lecture.